It is 11:45 p.m. Your massive final project is due at midnight, and suddenly your laptop screen goes completely black. The hardware is dead. You grab your phone, log into an app, and your project is sitting right where you left it, completely intact and ready to edit. We casually say this file is in the cloud, but that data actually lives on a physical reality, a coordinated web of thousands of servers working together to hold your information. Curious, this is a distributed file system, or DFS. When you save a document, the system breaks it down and scatters the pieces across a massive, coordinated network of global servers. The entire purpose of a DFS is to pull off a flawless illusion. It takes a sprawling web of machines located all over the globe and makes them act like one single, reliable hard drive sitting right on your desk. To manage this, the network follows 4 core features. Transparency hides your data's location, while scalability adds servers for new uploads. Concurrency allows multiple people to edit the same document simultaneously, and reliability ensures the network keeps running if machines break down. When your data first hits this network, the system analyzes its shape. If it is a text document or a photo, it uses an unstructured file model, treating the file as one continuous block of data. Alternatively, a structured file model is used for database files. These are organized into specific records and fields. Identifying these models allows the system to optimize storage. It can treat a simple text file as a single unit or index the individual records of a structured database so they can be retrieved independently without scanning the entire file. Now that your file is stored, the network has to figure out how to hand it back to you using one of 2 access models. In the remote access model, the file stays on the server while you interact with it from afar. This allows for real-time collaboration, like in Google Docs. In the upload-download model, you pull the entire file down to your device for offline editing and push it back later, giving you total control over the file locally. To speed up repeat requests, the system uses caching. Instead of fetching the data from a faraway server every single time, the network builds a shortcut. It is essentially the server getting so tired of you asking for the same document, it drops a copy right next to you. Client-side caching stores the copy directly on your personal device. Server-side caching holds the copy on the outer edge of the network, as close to your physical location as possible. By storing frequently used data nearby, caching cuts out the network delay, making a document stored on the other side of the planet open instantly. Hardware is fragile. Hard drives degrade, and sometimes a server rack simply catches fire. How does your file survive a physical disaster? The defense is replication. The system has already created multiple identical clone copies of your data across different servers. If one machine drops offline, another instantly takes its place. A major pioneer of this architecture was Sun Microsystems, who developed the Network File System, or NFS. NFS acts as a seamless translator. It handles the complex routing over the network so that you can interact with remote files as if they were sitting on your own hard drive. Without replication and translation protocols like NFS, the illusion of a single, stable hard drive would fail the moment a single component in the network broke down. That is the journey: stored by the network, accessed by the user, optimized for speed via caching, and protected from failure by replication. If you are studying this for an exam, remember the acronym F3CRN. The F3 stands for the core features, the file models, and the file access methods. The CRN reminds you of caching for speed, replication for defense, and NFS as the real-world pioneer protocol. This coordination is what allows us to treat a global network like a local drive, ensuring your work stays reachable even when hardware fails. If this breakdown helped you, drop DFS Master in the comments, and make sure to subscribe for more engineering explainers.